Well, here we are again, and this time we're going to be talking about solving trig equations. So as you can see here, I've got a question in front of us, ready to go, and it looks not too hard. So what we're going to do is start off by just solving it in a trivial manner that I'm sure most of you could probably pull together without too much of an issue, just with your solving equations prior knowledge. So let's do that very quickly. The first thing I'll probably do is a bit of rearrangement. I get 2 cos x equals 1. I've just added 1 to both sides of my equation. I divide by 2 and I get cos x is equal to 1 over 2. And then I could either put this into my calculator as x is equal to cos inverse of a half, or I could recognize that this is actually an exact value. And if I put that in my calculator, I should get something along the lines of 60 degrees or pi on 3 radians. So test that now. Check, pause the video, check that you get that answer, and make sure that you understand the exact value stuff that we've done previously to get that answer. That would seem like a good solution. Now my intention is to turn this into 3 videos, but I'm going to record them all in one go and then cut them up. This will be video 1. We're actually going to come back to this question in video 2, and we'll do the full solution and go right through it. But for now, we're going to break away and finish video 1 by talking about what this solution looks like on Desmos. So here's a Desmos page that I've prepared. And I'm going to have to do some playing around, but I want to remind you of how to play around on Desmos. So we had 2 cos x minus 1 equals 0. Now what about if we removed that 0 and looked at it as a function? So instead, we had 2 cos x minus 1 equals y. And you can see it was plotting it there anyway. So I've got that function sketched. It actually looks pretty good, but I might change a couple of things. I'll put it in projector mode, it's a bit bigger, put some arrows and labels. I'll label my axes, x and y, and I might also change my x-axis to go up in steps of pi so that I can see those exact points. It's in radians at the moment. I can change it to degrees down here, by the way, but obviously that's quite a small number of degrees shown now. So there's my radians. I might just reduce my y-axis a little bit, although I do like the size of it, but I'll go from like, I don't know, -2, no, that's clearly not going to work, 4 up to about 4, and we'll look at it like that. Okay, now the equation was 2 cos x minus 1 equals 0, and I want to solve it, but I've plotted 2 cos x minus 1 equals y. So why don't we change the focus here and have a look at what would this look like, or when does this graph equal 0? And so I'm going to do a second equation, second function, y equals 0 on here. So this is plotting 2 cos x minus 1 equals y and 0 equals y. And at each point where they intersect, I get a solution. And look at this. Desmos is giving me these beautiful solutions straight up. There's one of them, pi on 3. That is the solution that we already got when we first solved the equation. Now, here's the interesting thing. If you solve an equation using your calculator, just rearrangement and calculator, solving a trigonometric equation, you will get the closest answer to 0. Now, in this case, there are 2 answers that are equally close to 0. In that case, the calculator will choose the positive one. But the calculator will only give you one solution. What you need to learn is how to interpret that into the full range of solutions that you're trying to garner. Now, at this stage, let's say I just scroll along a little bit. You'll see I've got one solution here, and I've got another solution there, 5 pi on 3. Now that is also between 0 and 2 pi. If I go back to my OneNote page, you'll see I set up the domain here of 0 to 2 pi. And so that is also between 0 and 2 pi. In fact, you can see that the only time this function equals 0 is pi on 3 and 5 pi on 3. They're the only 2 solutions. So that's what we're expecting to get. But we have 2 solutions. The first one is here. The second one is there. Then we have a third one. It's outside of domain, but we have a third one and a fourth one. I mean, how many solutions do we have? Let's go along here. That was our fourth one just there. I've got a 5th solution, a 6th solution, a 7th solution, an 8th solution. Let's zoom out a little bit. Okay, so as it turns out, there's actually an infinite number of solutions. There's a solution, I can't even click on it anymore. I've zoomed out so much. But there are solutions in right up here, all the way up to there, right up to infinity. So there are an infinite number of solutions. So if a question ever asked you to find all of the solutions to a certain equation and didn't give you a domain, don't do it. It's going to take you the rest of your life. But there we go. So there are a great number of solutions, an infinite number of solutions. Your calculator will give you just one, and that'll be the closest one to 0, or if there are two that are equally close to 0, it'll give you the positive of those two. So that's the end of our first video. And I'd suggest now that you jump on and have a play with that. Maybe have a play with sine function, tan function as well, and just look at how many solutions there are and where they exist. And you should be able to see this line up with your work on the unit circle. All the best.